Here's why your engineering team thinks everything is fine while users are abandoning your app. You're monitoring the wrong metrics. While your P50 latency looks amazing at 45 milliseconds, that hidden P99 monster is crushing user experience. When 1% of users wait over 2 seconds, that's 10,000 frustrated people every hour leaving bad reviews. This disconnect between what you measure and what users feel is costing you customers. Peak traffic doesn't just increase your average load. It creates tail latency monsters that destroy user experience. During Black Friday, your checkout P50 stays fast, but P99 explodes to 15 seconds, causing massive cart abandonment. Trading platforms lose millions when market open spikes create 3-second delays for 1% of orders. Gaming tournaments become unplayable when P99 latency hits 800 milliseconds. The pattern is universal. High traffic plus shared resources equals P99 disasters that your dashboards miss but customers feel instantly. Here's what's actually sabotaging your P99 latency while your monitoring stays green. Garbage collection randomly freezes your JVM for 500 milliseconds. Users waiting for checkout suddenly experience mysterious delays. Database locks create cascading queues where one slow transaction blocks 20 fast requests. Cache misses trigger thundering herds that overwhelm your database every 5 minutes. Connection pool starvation means one slow query paralyzes your entire application. The real killer? These delays compound. 50 milliseconds network plus 100 milliseconds GC plus 200 milliseconds cache miss plus 500 milliseconds database lock equals 850 milliseconds of pure user frustration. Here's how the tech giants actually solve tail latency at massive scale. Netflix uses smart load shedding. When CPU hits 90%, they automatically drop 10% of requests to keep P99 under 500 milliseconds for everyone else. Google Search employs request hedging. If a request takes over 100 milliseconds, they send a duplicate and use whichever responds first, cutting P99 by 60%. Amazon's DynamoDB prevents cascade failures with adaptive circuit breakers that fail fast with cached data instead of 30-second timeouts. Uber dynamically adjusts timeouts based on recent P95 latency rather than using fixed values. The secret? Layer multiple strategies. Hedging plus adaptive timeouts for read-heavy systems. Load shedding plus circuit breakers for write-heavy workloads. Your users are abandoning your platform because of tail latency while your monitoring dashboard shows everything is green. Don't let 1% of slow requests become 100% of your customer complaints. In System Design Interview Roadmap issue number 105, you'll master the complete long-tail latency playbook, from understanding why P99 matters more than P50 to implementing the exact strategies Netflix, Google, and Amazon use at scale. You get hands-on implementation with working code, real-time monitoring dashboards, and production-ready patterns. Stop guessing about performance issues and start building systems that deliver consistent user experiences. Join 50,000+ engineers who rely on these insights to architect better systems.